Hello, in today's video I want to talk about organizing game data and code when developing for the Playdate console. I'm not going to focus at all on the Pulp framework, and that's because I have already made a video about logic containers. You can find that video on my other playlist, which is specifically made for Pulp game development. It's called Pulp Tips and Tricks, and there is a video there. It's the first one on the playlist, and it's called Logic Containers. And in that video I go into slightly more detail about what those logic containers are, how to use them, and how to implement them. So today I'll be focusing on the SDK, and I will be focusing on the SDK with the example of the sequel that I've made to Magic Castle, which is the Fall of Magic Castle, that was made entirely in the SDK. So this is going to be a coding video. It's going to be mostly about coding patterns, coding decisions that I've made. I'll try to keep this well structured and separated in chapters, so that even if you're not interested in all of this, then maybe there is going to be one particular section that you're going to find interesting. And well, since this is my code, I could talk endlessly about it. I could talk about it for hours, but I thought it would make the most sense to go through the Main.lua file that you can see right here. This is the entry point to every single Playdate game made in the SDK. This is where all of the fun begins, and all of the coding structure actually begins. I call it simply an entry point to the whole code base. Usually I start with importing lots of different libraries, data, utilities, and this is exactly what's happening in here. First, we're just loading those core libraries which are necessary specifically for certain parts of the SDK to work properly, like showing the keyboard, allowing to show and edit the sprites, the graphics library. You don't have to load all of them, depends on what you're actually using in the game. If you're not using the crank, then you're not importing the crank library. It's as simple as that. I also have a couple of helper libraries. I've already made a video about LDTK, so you can get more information about this specific library in a separate video I've made. It's called editing and creating levels, or just creating levels. So that video is completely dedicated to LDTK. I'm gonna make a separate video about panels, because that was actually working with that library was one of the highlights of my development time with the Fall of Magic Castle. Here I just want to briefly mention AnimatedSprite and Playout, both very helpful. AnimatedSprite is a helper library that is supposed to help you with managing your sprite. It makes managing sprites a little bit easier. It's not something that you absolutely need, because you are able to manage your sprites just fine using the SDK, but I would say that this makes that sprite management much easier, much more clear, to be honest, and also much more manageable. I don't know, the author abstractified certain things about managing your sprites in a way that just made it a joy to work with. So I can really recommend using this particular library. It has a good documentation, it has clear installation steps, and working with it is just fun. And I'm really glad that I already knew about this particular library before I even started development. I had this research phase before I jumped into the SDK, and not all of my findings were as successful as this specific library, but yeah, I'm very happy that I came across it. And the other one is called Playout. It's a box model UI library. It was made by username Poch, and for me, since I'm coming from a web development background, this was something that I wish I had found sooner. So this is not the same case as with the AnimatedSprite library. I found this much later in the development because I was trying to solve a specific issue of easily showing a list, a menu, that I couldn't do it as easily as I wanted with the default SDK. Here in the game, when you want to access the menu of the game with the potions and the magic and the quests, this was very difficult to do for me with just the SDK, and then I stumbled upon this library. I was looking for something to fix my problem a bit faster, and with this library it was really easy to do. So I honestly wish I found it sooner, because then I think I would implement it in more areas, and it would definitely also speed up the implementation for certain features for me. So especially if you're coming from a web development background, I think you should take a look at this library. It might be a real time saver, especially if you're going to have more than one menu in your game and you want that menu to be a bit more interactive. When it comes to the data and the utilities, this is something that I also took from my web development experience. I knew that since my game is a narrative game, there's going to be a lot of data, meaning that you can talk to NPCs, for example. Different NPCs have different things to say. The placement of the NPCs and enemies has to be somehow orchestrated throughout the whole game. The game has to remember if an enemy should still be there, or if the enemy was defeated and should not show anymore. There are objects in the game, like things that you can find, power-ups, upgrades, health items, things like that. So all of that needs to have its own data structure, so that I can in a manageable way represent all of the game's items and entities, and just have specific files for managing those specific aspects of the game. There is also a file called animation trigger data and teleport data. Teleport data is all about it's all about places where you teleport into another room, but not by going through the edges of the level. Because here, for example, if I go through the edge of the level, I suddenly end up in a new level, and the game knows that if I reach the edge, then it should go to the next one that is south of my current position or north of my current position. That is automatically made in the code. But there are a couple of places, like right here, where you're going into a cave, and the cave is not at the edge of the screen, and I solved it by creating those empty sprites that you cannot see. Here you have those purple borders that help with development, because they show the collision sprites, but if I turn them off, then suddenly it is as you would see it on the device itself. So there is this small rectangle here, and if my character collides with it, and it can collide with it, it's not a wall sprite, it's something that you can bump into basically, then there is this instruction made to position you into, teleport you effectively into another screen, and the exit works the same way. It brings you back to where you just have been. This also needed its own data structure, because I was working with the placement of those teleporters. I had to move them around a little bit. Sometimes they had to actually lead to a different place than before. So I wanted to have a separate place to manage my data. And there's also something called the animation trigger data. In my game, similarly to those teleport sprites, there are animation trigger sprites. When specific things happen in the game, that can trigger an animation. And an animation is The way that I wanted to implement this was taking control away from the player and just showing a cutscene where every entity on the screen can move, can change its state, so it can change from standing or being idle into walking right, walking left, and then I can move them around. So as you can see here, I just passed through an animation trigger sprite, which is just this long purple line, and suddenly the sister wants to play a game. So the dialogue system is still functional. I can trigger it at will. The only thing I cannot do is that I cannot move. I cannot take any action except for forwarding the conversation. In this case, the game switches into a mode where I can play a minigame, which is Pong. So that's one use case of the animation trigger. There are other animation triggers where things are happening on the screen. You're not transitioning into a different gameplay mode. You're just having a conversation. Things are moving around. Maybe there's some sprite animation happening. So all of that, all of the data about what is supposed to happen is structured in those data files. With the teleporters, I specify the name of the level, the name of the entity or the teleporter, where is it supposed to be placed, how what are the dimensions of that trigger, and where I want to jump to, which coordinates I want to jump to at which scene, and do I even need to confirm that I want to go there. In some cases I do want to confirm that I'm going somewhere, like for example if I am here, you can see that there is the A button confirmation now playing to just notify that, oh, you want to go in, then press a button and you're in. But for example here at the exit there is no such trigger. This was made to prevent the user from frustration. If the trigger was automatic here, then every single time you would step out of the house you would immediately be brought back in, so then you would never be able to escape it. Otherwise I would have to send the player like to this position or maybe even to the next screen, which would feel a bit off. So I've made this additional flag where if confirm required true, then show this. I'm pointing at the screen, but that doesn't make sense in this context. Then you can see this A button confirmation trigger here. So this is how the teleport data works, and it's the same for every single other level. It's just a collection of data. With the NPCs, it's a bit different, because with the NPCs you have the ability to talk to them and they will display different things. So not only can you position an NPC using this data structure, I specify the coordinates, I specify the image that is supposed to be used for the sprite animations. I say whether or not the sprite is a standard sprite or a non-standard sprite, because most sprites for the NPCs are coming from a specific sprite pack, and they look more or less the same. They have the same dimensions, they have the same animations of standing idle down, standing idle left, right, up, and then moving around. So when they are standard, they are treated in a specific way because there is a exact same amount of files per sprite to work with. But there are also some non-standard sprites. Usually those are the enemies. The enemies have different dimensions, they have different animations, they can do different things. So in this case I wanted to separate the standard sprites so that I can process them faster. The non-standard ones needed my attention anyway, so it made sense to just separate those concerns a little bit. And every single NPC has, or maybe not every single NPC, maybe I do have one or two NPCs that don't say anything, but I think that most NPCs say something, and they do say something by default, but also in some cases they say something according to the quest that you're currently on. There are quests in the game and you can progress those quests. Some of those quests have multiple stages, and you can have a different conversation with specific NPCs depending on the quest progress path, especially if the NPC that you're interacting with at some point will also become a quest giver or a quest manager. In those cases, you want them to say different things depending on where you are in the quest. With the enemies, it's a bit more straightforward. There's an enemy types list where I just say what kind of stats each enemy has, what kind of damage they do, what kind of an image is going to be used for them, and also how often will they attack, what's going to be the interval between their attacks. And then same like with the teleport sprites, there is just a long dictionary or object full of data where I specify what kind of enemy can be found at what coordinates in which level, and that's all I needed to manage the placement of the enemies. With the animation trigger data, the one that you saw that transitioned into the Pong game, it's a similar approach. As you can see, the approach is similar, but it deals with very different aspects of the code, right? I'm either thinking about moving my character or interacting with the world or displaying, rendering enemies on the screen, but the concept behind it is using always the same thing, one massive object which has additional sections which are usually done with the name of the level as a key, and then in the as the value of that key I usually put in another object in which I specify even more details about what should be shown where and how should the player interact with it, what should be the outcome of that interaction. The object data works exactly the same way. What should be shown where, should it be visible? Sometimes some things are invisible until the player does something in a specific quest or in a specific trigger, and then the object becomes visible. So all of this is mostly just data management, but the logic behind, like in this case, in the data files, I've shown you what I want to show and what should the player see. In the Utils section, which I'm not gonna get too deep into because this part is mostly the logic that coordinates all of those aspects that I've shown before. In these files, there is a lot of logic that manages the showing, the drawing and the clearing of sprites, for example, the triggering of teleport, all of the logic that supplements how the game works, how the game ticks. For example, if I have the let's say for example I've got the music manager. In the music manager I can, where is that? In Utils. Okay, here and then here. In the music manager I have a collection of sounds and sound effects, but then I have a couple of functions that I've made about resuming music, pausing music, stopping music entirely, stopping all music, and also a music dispatcher which will basically think about what should be played at which point of the game depending on where you go, if there's an animation or not. So all of the logic that surrounds music is placed into one music manager file. When it comes to for example the dialog box, the dialog box that you see when talking to a specific NPC, that whole box exists in the dialog box file. How it should be displayed, how it should cut text, how it should paginate the text, what should be seen, how it should affect the player, that when there's a dialogue then the player cannot move. All of those things related to the rendering of the dialog box are in the dialog box file. That's how I usually try to separate the logic of the game and have the data in a separate place. Just to basically summarize the synergy between those files, in NPC data I would just write in the conversation object what should be said, but then in the utils folder, the dialog box file would pick up that information about what should be said, and then using its own internal logic, it would display all of that data onto the screen. So that kind of separation of concerns really works quite well for me, because otherwise, if I hard-coded specific data points into the logic, it would be difficult to for me it would be difficult to manage the data, especially because in the beginning of the game there is no dialogue, there is no conversation, there's just placeholder text, or just I was writing some keywords in my native language in Polish just to have a general framework of where to go, what to do. So that kind of separation really worked quite well for me. The same thing I can say about minigames, because this game has quite a few minigames. The first one that you saw on the screen was Pong, and for the minigames I had to also create a separate folder with separate files, and each file is its own minigame. I wanted to have a system in which all of the minigames are isolated, and they don't spill out, their code, their logic doesn't spill out into the main game, because I started with the minigames. I didn't, well, that's not true. I started with a vertical slice with the most basic of systems, like movement, collisions, doing LDDK for level management. But then to really dive into the SDK, which was my first encounter with this kind of coding, I wanted to start with those minigames. I did the minigames first, and then I worked on the combat system, then I worked on the quest system, because I wanted to see on specific sealed off examples what can I do with the code without messing something up so profoundly that the whole code base is then locked out of any easy modifications. I wanted to have small isolated examples, and that's why those mini games came to be, not just for the fun of the player, but also as a playground for me to learn how to manage the code in Lua, and how to call specific SDK functions for the Playdate. Then we have the quests and entities. Entities are a bit like utils. They just describe how what is the internal logic for moving the player, for the player combat, for encountering certain things, and the biggest of those files is definitely the player file, because the player does a ton of different things. The player can move, the player can interact, the player can be rendered or cleared from the screen. The player can interact with objects, with NPCs, but also with enemies, so that triggers the player into an enemy combat state. So there's a lot of logic for especially for the player, but thankfully I've used the AnimatedSprite library, for example, and that already simplified the code for me quite a lot. So we're past the point of importing all of those things. They have to be then used in the code in specific places, but I'm not going to get too much into that. I just wanted to show you how I separated specific chunks of the code, and then they're used in specific places, but the imports already show a bit like a table of contents of a book of what kind of things are in the game and how they are separated. Then we have tags. Tags are very useful. You can, when you have sprites, you can tag them. This is supported by the SDK. No specific libraries are necessary here. You can tag them as numbers, and this is super helpful because whenever you collide with something, the collision system can then call up the tag of what you're colliding with. So then the code knows, oh, the player, which is tagged as a sprite with the ID of 1, is colliding with an NPC, which is a sprite with the ID of 2. In this case, you're not supposed to fight them, you're supposed to talk to them. If it's an object, you're supposed to pick it up. If it's a teleport, then you're supposed to do this, this, and that. So it was just a nice way of organizing all of the collisions, because when you think about trying to go through walls and bumping off them, when you think about moving through those teleports, when you think about attacking an enemy, those are all collisions. You're just colliding with another entity, and your code has to determine what to do with all of that. Then we move on to one of the most important parts of the code. This is something that a lot of developers might not agree with. This is how I organized most of the temporary and not so temporary variables in my game. I've just created one massive object that I called state, and this thing holds everything about the game, or most things about the game. It has all of the information necessary to display certain things, to keep track of certain things, and to also save your progress. The reason why I did it like that is because this is something that I know from web development. Again, so I'm just transferring some of the things that I found in another realm of coding into video game development, which is not what you're supposed to do in some cases. I can fully admit that some of the ways that I've done those things are not the best, are not ideal. But when you're dealing with a solo project like this one, this is actually inevitable, that at some point you will not have enough input, not enough feedback, not enough knowledge to do certain things in a certain correct and right way. And in this case, I just decided to do something that I knew quite well from my daily job. So I just created one massive object, and that massive object has a lot of data. It has all of the data about the player, where the player is, because this is not something like where the position of the player. This is not something that you can put in a file as a data file and hard code that. You can do it with a conversation, because this conversation with the save guy, you want to save, hold still. That's always going to be the same. That's a constant. That's something that's always going to happen. But when it comes to the player position, the player is not static. The player can move around. So with each press of the D-pad, you're just moving around the screen, and that position has to be dynamically updated and tracked in the code. Otherwise it would not make sense, right? You always need to have some sort of an indication in your code, in your variables, where you are and what you're doing. So everything from the game state, through animations, through all of the player and NPC aspects, through some data is pulled from the data files and into the state, because otherwise otherwise you would end up in a situation where you play the game, you save the game, and then you come back to the game and some things just restart, like some conversation restarts, some placement of enemies restarts. I wanted to have persistence. I wanted to have a game where you can stop midway and then come back and have the world state in exactly the same state as it was before you exited. So I wanted to have this kind of persistence. Saves and teleports, dialogues and quests, combat and enemies, spells. There's a lot of information here that gets saved in this one massive object, and there might be other ways to do it. There might be even better ways to do it. There is always, for example, the risk of putting a typo, for example, or removing something. Removing something that was very important with just an empty value. For me, it was not such a big deal because I just worked on it alone. There was no collaboration with anybody else. So whenever I did a mistake, it was pretty easy to try to trace it back. I probably had to test more than test more than if I used some other way of managing my data and state. But there are also advantages to this kind of approach. Whenever I wanted to say that something has changed about the world state, I just had to call state dot, and for example, in one of the logic files, let me find something where the state is being changed. Let's think about the player. For example, here, if you pick up some loot, then there is a sound that plays, play sound, find gold, but also the state player money, which currently might have the value of 10, suddenly gets incremented by the value of gold that you found. That was also a static value. Let's say that it was 50, and if you found something, then the state.playerMoney variable would be incremented by 50, and that's it. Suddenly you've got 50 gold. That made it easier to test as well, because I could hard code certain values and start the game with all of the gold, all of the abilities, all of the spells, and certain features unlocked just to test them. And finally, having this one massive piece of state was also quite useful for saving. I was a bit worried about how I would even manage saves in a game like that. So I did the same thing as I did in Pulp. I just saved this one big massive variable. That's why when you play the game, you might sometimes have this kind of a situation where you hit save. He tells you to hold still. That was my way of trying to prepare the player for what's gonna happen, because the game might freeze for a second. It might save up this one massive file, which is I think over 1 megabyte actually, which is quite a lot for the Playdate. So if the game crashes during saving, I guess something gets corrupted, and it might then not load up properly. Thankfully nobody has reported an issue like that yet. But we'll see. If something happens, then I'll try to optimize the code even further, maybe split it into smaller chunks with the state, some refactoring just to make it work a bit better. But for now, I'm satisfied with how I approached this problem, because it was a complex one, and I was frankly, I was just happy that it worked. At the end of the day, that was the most important aspect of managing all of my game data. I just wanted it to work, and I wanted it to work reliably to a point where I can ship that game and be happy that others can experience it. So this is the state. Lots of things happening here, and then we have the main loop, and in the main loop of the game, which is updating very often. I have a couple of functions that are specific to the minigames. Like if the gameplay mode is Pong, that means that I'm not here, that means that I'm in the minigame mode, and then that's when I should update the Pong game, which is things like move the ball, move the paddles, update the score, trigger the game over screen, and so forth. So all of the minigame logic updates in real time if you're in that gameplay mode. But otherwise, you can also be in the main menu, for example, and then it's just about triggering the scene manager, which will then dispatch a call to the LDTK to the LDTK functions to release certain things and then load certain things, and then just move you to the actual game screen. And when we're in the else block, then I am updating all of the normal overworld game logic, which is updating the player, so updating the player's movement, responding to the inputs and whatnot, updating the enemies, they have their own movement patterns, update Fireball, this is about the spell, Scene Manager is about transitioning the screens, Timer Manager is about timing and counting and recording time when you're for example using a spell. Then there's a timeout for that spell. The Timer Manager is a way of managing those different timers so that everything runs in sync and smoothly. Drawing the dialog boxes for always having the dialog box prepared to be shown if there's some text to be shown on the screen, and there's also combat options and running animations. All of that is for either engaging with the combat systems or engaging with the menu, with the game menu. So all of that makes the game tick. All of that makes the game run. There is also one more thing I wanted to mention, and this is about the general file structure, where data is done separately, is collected separately. Entities, which are the enemies, NPCs, objects, and players. There's a whole images file, which also has its own subfolders, where all of the images are semi-categorized and where they should go. The LDTK Lua levels and levels, those are coming from LDTK, and some of them are just Lua files that were modified by the framework so that they load quickly on the device. A separate thing for the minigames. There's also a quest managing system. So there's a lot of systems in play, and I would, in a way, I really wish that I had somebody else to work with, to collaborate with on this project, because especially somebody who has at least a little bit of video game dev experience, because I might have been my worst enemy in some cases when I was structuring this code, when I was thinking about how to approach certain things in the game. I just didn't know any better. So there is a limit of what you can find when you browse through documentation, when you read through forum posts, when you try to apply existing knowledge into something that doesn't directly apply, to be fair. So there are limitations like that, and nothing beats another human being who is also dedicated on working at the exact same thing, and just being able to collaborate on that. So yeah, it would be great to for the next project to think about this kind of collaboration, to spread the wings a little bit and do more complex stuff, because that's also it, right? If you find the right coding partner, the right coding team, then each person brings so much to the table that you can do so much more than it's more than the sum of its parts. That's what I am ultimately trying to say here. So yeah, I'm pretty happy with how I structured the code. I'm pretty happy with the final result. There were some bumps along the road. There were some things that I really didn't know how to tackle, or I tackled them too late. But I guess that's normal. Video game development is not as standardized as web development, for example. There are some best practices probably, but since I haven't worked in the industry, I don't know those best practices. I don't know how to approach certain problems, but that's okay. I guess that's the allure of the Playdate ecosystem, that you don't need to know those kinds of things. The device is constrained in ways that actually help you think about your game in an isolated way, where you don't have to think about all of the systems that a AAA game might have. The project is much smaller in scope, even if personally this feels gigantic to me. In comparison with industry level games, this is really small. So that also helps with mentally managing all of that code. Okay, that's it for today's video. I hope to see you in the next one.